So we have formatted the name node right now, and we have selected the master daemons, the name node, job tracker, and we have started the slave nodes, data node and task tracker. So it's a general HDFS architecture overview. So we have started the name node, and uh, we have started the data nodes. Sorry, only one data node. We have set up a single data node cluster with the slash data slash d1 and slash data slash d2 configuration. So name node is a master node here, and the data node is a slave node. So HDFS is a distributed file system. When you put a file into HDFS, that file is distributed across the nodes. Uh, in our current cluster setup, only one data node is there. So we have set only one data node. So when you put a file on a HDFS Hadoop distributed file system, it only copies to one data node, and that resides under slash data d1 and slash data d2. It's a local file system. HDFS in turn uses a local file system. Local file system may be your ext3 or JFS, whatever. Usually ext3 is used. Okay. Some very basic configuration walkthrough. We'll see into what are all the minimum configurations are required as of now to run a cluster. We already ran a cluster, so we'll go into some of the configurations. We'll check in the terminal. So the first thing is Hadoop env.sh. It's placed in user lib Hadoop conf, and here are some configurations. We already seen that Hadoop runs on Java. So Java underscore home you have set it up, which is a path to Java runtime environment, and these are JMX settings. As of now, you can ignore this. And so if you want to change the logs of a process, maybe a data node or a name node, you can just uncomment it out. So by default it will be in Hadoop underscore home. Hadoop underscore home is user lib slash user slash lib Hadoop is Hadoop underscore home, and there you can find out the logs. So you can change it to uh, any other directory like slash home slash hdfs logs, or whatever. Rest of them. So here when you run a daemon, there is the one when you run a daemon, uh, the PIDs are placed in these directories, so you can change it out, and the default settings are pretty much good here. And one more very important configuration is you can set it heap size for each of these daemons, like for Hadoop name node, we can set it up a heap size of 2 GB. For data node, daemon, we can set up JVM heap size of or 2 GB or 3 GB, something like individually we can set it out. And here is the one where you can set the heap size for uh, entire name node, job tracker, secondary name node, data node, or whatever. It's a global heap size setup. So it's better to do an individual heap size setup than a global thing. Okay, just commenting it out here right now. So you can see the logs here. Use slash user lib hadoop conf, sorry, hadoop logs. Just change the directory. I'm just copying it right now. Okay, so here is the log for, let's see, a name node log. Tailf. This is the name node log. Okay, and let's see the data node log. So I opened using a VI editor. So it says RPC server starting. So this is just a log. Okay, so now coming to the previous directory, the user lib hadoop conf. So let's look into hdfs site.xml. Okay, so coming down, this is what we need right now. dfs.name directory, as we saw previously, the fs image and edits of the name node, that is a metadata, is stored in this directory. And the data node specific configurations, uh, so slash data slash d1 hadoop data. So hadoop data is, it's an hdfs data. So the hdfs files are stored in these data directories. So you can define slash data slash d1 d2 d3 d4, or like that you can define it out. So slash data slash d1 in production systems, it's usually a disk, a separate disk. Okay, and those parameters very important as of now. So come to mapred site.xml. So the job tracker Earl is master slave, what the current host name where the job tracker is running right now. So it runs on a 54311 port. So you can change the port if you want. The task, this one, mapred.local.directories, the task trackers running on the node stores some temporary intermediate data. So that path we can give it out. So where the task tracker should store the intermediate files while running MapReduce jobs. So this is slash data slash d1 MapRed local. and slash data slash d1 d2 map local. Okay, and rest of them you can see it later. Another one, yeah, yep. And another one is core site.xml. Yeah, so in core site.xml, the hdfs URL is defined here. So again, the port number where the name node should run. The master slave is the host name of the name node. So where it's currently running right now, and the edits directory. So it's Hadoop, a temporary directory. I can place it here slash data slash temp. So by running all these daemons, you have set up a single node Hadoop cluster. So you ran a name node, you ran a data node, and a task tracker and a job tracker. So name node and job tracker gives you a user interface, a web user interface. So let look into it. So log in. So switch into your Ubuntu host, Ubuntu virtual host. So you can make it as a full screen here. Okay, it's a full screen. And here at the left corner there is a Firefox browser. Just open it, and the host where you have installed the name node, the host name is master hyphen slave colon. The port number should be 50070. Okay, and this port number, don't confuse with 54310, which is given in mm, the core site.xml. So that is different, and this is different. So 54310, 54310, 54310 is the HDFS port. So we'll look into it sometime later. So how HDFS is accessed through command line. So this is a user interface. So similarly, you have a task tracker interface. The same on the same machine, the job tracker is running. Slave, the port number is 5430. That was 50070, and this is 50030. Just hit enter. Okay. Yeah. So coming to the name node URL, you can browse a file system here. HDFS is nothing but a distributed file system, so it contains directories, files in that. So as of now, only a user directory is there. So it says a directory, a mapper directory. It's a file, it's an empty file. Okay, come back, and you can browse the file system. You can just like check the name node logs here. The name node logs, you can find it out here. Okay, so as of now, it's a cluster summary. As of now, we have 4 files and directories. So all these, the heap size is 15.553 MB used of 1 GB. It's just a 1% usage. So all these will look into later parts. So you can ignore all this as of now. Okay, and I will tell you one thing is like the configured capacity is 15 GB. This is the one you should really care about as of now. Okay, the live node, this thing, live node. So we there will we have a single node cluster right now. So only one data node is present. So if we add more data nodes to a cluster, you will get a list here. Okay, and storage directory. As I said in hdfs.xml, uh, we have set it slash data slash d1 Hadoop data, where the uh, image and edits file, that's the metadata of a name node, is set up. So this is the metadata image, and so it's active, it says active. So the same here is replicated to slash data slash d2. See, suppose in a production environment, disk slash data slash d1 is mounted on one disk and slash data slash d2 is mounted on another disk. So uh, so so if slash data slash d1 goes down, we can recover the metadata through slash data slash d2. So it provides high availability of a data. Okay, so all these configurations we'll look into later chapters, because you don't know what is a block size, what are all the blocks and all, so we'll look into it later. Okay, and version is there here. So we are using Cloudera CDS 3 U5. So okay, so the Hadoop client, any HDFS client can access the Hadoop file system through uh, this URL. Okay, so coming to a job tracker. So job tracker URL is 50030. Okay, right now the state is running. So the date started when it was started. Same here, the version. Okay, and the heap size of a job tracker, the JVM job tracker, is 12.69. So we have only one task tracker for a job tracker as of now, because we have set up a single node cluster. So all these will go study in later chapters. I will explain in later chapters. Scheduling information and the jobs, running jobs, the jobs which are retired. We have not submitted any jobs as of now, so we'll schedule a job later. Okay. This is a name node user interface, and this is a job tracker user interface. And congratulations, you have set up a single node cluster. Okay, let's go to the next slide. Hmm, okay, so directories under slash data. Let's look into the directories under slash data slash d1, and uh, what are all these directories are for. Okay, let's go cd slash data slash, let's do it here itself, ls-li slash data. Before that, so let's do a df-h. So df gives you the list of mounted file systems. So slash data slash slash data is the
file system mounted on the disk slash dev slash sdb. So we purposely created one virtual disk and mounted it on a slash data. It's always recommended to separate the mount partition from root. So this is a system a slash file system slash root file system, and this is slash data, particularly used for storing Hadoop related data. So it's always recommended uh, to make a separate partition for HDFS or any Hadoop related operations to be written or read to the disks. Okay. So here is slash dev slash sdb. This is a separate disk mounted on slash data. Okay. So ls hyphen li slash data slash d1. Okay. So this is Hadoop data. Hadoop hyphen data. So under that, Hadoop hyphen HDFS. So DFS name. So current. Okay. Look at this path. So this directories are only used by the name node, not the directories. Uh, from here, it's only used by the name node service wherever it is running. So edits is the metadata, as I said you. Edits and fs image, we'll look into it this in the next chapter. So what are all these edits logs, and what is fs image, so why they are created. Okay. So coming back, Hadoop HDFS. So current, just have a look into these directories. See, here it's DFS name current. Here it's only current. So this is specifically, this directory entry is specifically used by the data node daemon. This was used by a name node daemon to store edits and fs image. That's what we call as the metadata of a name node. So this is for uh, keeping the data node files. So each file is divided into blocks and kept on a disk. So as of now, there is only one block, and this is the version of a data node. So when you can see it here, do vi, and when a name node starts, it gives the name node ID. So do you have a data node has a storage ID? Just these two things, you just remember it. And this version layout and all, it depends upon which version of a distribution you are using. It's Cloudera distribution. CDS3 U3 has a different version layout, and CDS3 U5 has a different version layout. That's not important to us right now. These two are important to us. So namespace ID, when a name node starts, right, it gives you a unique name ID, namespace ID, and storage ID. When a data node comes up, it it gives a different unique storage ID that's are stored in the version. Okay. And coming back, you have, sorry, slash data slash d1. In that, previously we looked the directories under Hadoop hyphen data. Now it's MapRed. MapRed local. Under this directory, task tracker keeps the intermediate data while running the tasks. Okay. And one more thing, uh, so to check the daemon services running or not, you can check it in different ways. Uh, so one is a JPS. So task tracker name node, data node, and job tracker is running. So another one is a very important command, ls of list of files hyphen I, give the port number 54310. As you remember, 543, which is a port number uh, binded to a HDFS service. So should be in the listening mode. So see, your data is the HDFS and the command is Java. So it's listening. It should be listening mode. It should be in listening mode. Okay. And task coming to job tracker 3.1 we have set it, so that is also in listening mode. So right now, uh, name node listens on 54310 any input connections. It listens on the TCP port 54130, and job tracker listens on 54311. So ls of is a very important command which can be used while troubleshooting on a Hadoop cluster. Just make a note and go Google it and read the man pages of ls of, and just practice it. You will come to know what exactly the command is. It has various switches and it's a very important command.